Hey guys, welcome to your Chapter 7, Lesson 5 notes on rational exponents and radicals. Fun fact, rational, you look at this word rational and it looks like ratio. That's where we have a fraction, so if you have like A over B, that's that. So we're going to have exponents that look like that. Okay, and then a radical symbol looks like this. We've seen it as like the square root guy, but it's not always for square roots. It can be any number that you want, any integer. So let's just, you know what, guys? Oh, just kidding. Goal. By the end of the day, you'll be able to rewrite expressions involving radicals and rational exponents. Okay, so let's just jump right in. When you have this guy right here, you've already seen the radicand, this square root symbol. He's called the radicand. No, just kidding. It's called the radical symbol. I lied. Don't worry about that. Radical symbol. And this guy right here, n, he's called the index. I'm just kidding. Index. He's called the index. And then what's under here, in this case, A would be called the radicand. Am I ever going to ask you what this means? No. But I might start talking about the index, so you should at least be able to know what an index is. Right? You have seen this kind of thing before, when you've seen like the square root of 4. Now, I want to pick a different number. The square root of 9. Okay. When there is no index here, that's like a hidden little 2, the square root of 9, which is 3. And what this is saying, if we want to figure out, hey, what is the square root of 9? We say the square root of 9 is 3. We do. The square root of 9 is 3 because you take this number, which multiplied by itself twice, hence your index of 2. So what times itself equals the thing that's under your radicand, or it's that you're literally the radicand. What times itself twice is 9, and that would be 3. Or negative 3. Fun fact. Oh well. Okay, so when you're going here, when you see this symbol right here that says, hey, you're looking for some number that when you multiply it by itself n times, you get a. So we call that, look for n equal factors of a. So here, when n was 2, we're looking for 2 equal factors, so 3 appears twice to get 9. Let's translate this. Here, we want to find 3 equal factors, 1, 2, 3, of 125. So you want to figure, okay, what times itself 3 times is going to equal 125. That number is 5. So 5 times 5 times 5 is 125. Ta-da! Because 5 cubed is 125. So our answer here, 5. This is equal to 5. What about the 4th root of 16? We're going to find, okay, what number multiplied by itself 4 times is going to give us 16? One of you asked me earlier in class this week, do we just have to guess? I just have to like trial and error, guess and check? Yeah, basically. But that's okay too. 2. Okay. So here, what are we looking for? We are looking for some number, 2, 3, 4, 5, that when multiplied by itself 5 times, we get 32. It's 2. So the cube root, not cube, just kidding, the quintic root, the 5th root of 32 is 2. Oh, that brings me a little reminder here. This guy here, when you have n radical a, we say that is equal to, we read that as the nth root of a. So here your index is your nth. This means root and of a. So root of a, nth root of a. One more. Hi guys. Look at my nephew in his tiger mask. Okay, cool. What are you trying to find here? You're trying to find 1, 2, 3 some number that when multiplied by itself 3 times equals 64. Can you find it? I found it right here. That's not why it is what it is. That's a coincidence. But it is, in fact, 4. So that's fun. Okay, cool. This can get kind of clunky and kind of hard to read sometimes, especially as we're doing a lot of different multiplications together. You'll also remember this process when we would do this same kind of process when trying to find something in previous lessons. When I asked you, hey, what is 64 to the 1/3 power? We would still do this same thing. You would say, okay, well, what number times itself 3 times is going to equal 64? So notice that the radical with the index is this same fraction of an exponent. So down here, well, this is not an equals. This would be like, think of it this way. Okay? If you have the nth root of a, again, that's the nth root of a, you can write that as exponents. That's the same thing as a to the 1 over nth power, a to the power of 1 over n. Similarly, and if you want to, actually, hold on. Similarly, if you have the same kind of thing, but instead of a to the 1st power, you have a to the mth power, whatever m is. You raise a to the mth power, that's m over n. Ha, cool, right? You might also sometimes see this guy. So right here, I have the exponent underneath the radical symbol. He can also go outside of it, and it's still that same expression. So that's okay. Yay, look, our key ideas of the day. So let's rewrite these guys with exponents. We're going to, oh, they have exponents. Done. I'm just kidding. Let's write them in radical form, and then we'll write the radicals with exponents. I got so excited. We got ahead. Okay. Remember with exponents that exponents only apply to their variable unless they're in parentheses, but here there's no parentheses. So we're going to leave the 12 alone. That's the same thing as 12 times. And then let's look at our pattern. Here we've got the 2/3. So here 2 is going to go on top. Thirds is going to go on our bottom. So that's going to give us the same thing as if we follow our, nope, not equals. We need to find our index. Our index is always going to be the denominator. And then we'll draw our radical symbol. Then we've got our radicand, which is the base. And then our numerator is going to be our exponent. So this gives us the 3rd root of a, oh, just kidding, the 3rd root of a squared. Because again, the radicand, the guy underneath the radical, he's going to be their base. That index is going to be the denominator. And the exponent, oh, hey, look, exponent, numerator of your exponent, that is. Let's do another one. See if you can follow the same pattern and set it up. But check it out, check it out, check it out. We've got parentheses. So this is our whole base of our power. That means the whole expression, 64a, is going to go underneath the radical. And since we've got a 4 as a numerator, 4 is going to go, you can put him outside, and that's fine. Or you can say, hey, this whole expression to the 4th, that's fine as well. And then, because 5th is the denominator of our exponent, our index is 5. Ta-da! Isn't that great? That's great. But guess what? It doesn't stop there. It gets even more simple. Because we can simplify the 5th root of 64. So actually, I'm going to take a step backwards, and I'm going to say this is the same thing as 64 to the 4/5 power and a to the 4/5 power. So you know to take your here, I'll zoom out just a little bit, to take your base, and that goes underneath your radical. And you know, hey, I need to take the numerator and write that as a exponent, and I need to take my denominator and write that as my index. Cool. So we can't, sorry, went zoom crazy. So we can't simplify this anymore unless you make it all one color and call that simplification. That's not mathematically accepted. But now we are looking for the 64 to the 4/5 power. So I'm actually going to simplify that over here a little bit. If we're trying to find 64 to the 4/5 power, well, we want to find, okay, what is 64? What is the cube root of 64? Wow, I made this way hard. I'm so sorry, guys. Because 64 doesn't have a clean quintic root. I should have fixed this problem. So this is the same thing as 32 times 2. 64 is 32 times 2 to the 4/5 power. We're going to leave 2 to the 4/5 power alone. And 2 to the 4th power. I'm sorry, this got way complicated. So I'm splitting this up. Instead of 64, this is 32, and then we'll do 2a to the 4/5 power. So this becomes 2a to the 4th power, like that. Gross, that was so gross. Okay, anyway, the 5th root of 32, did we find that earlier? We did. Look how convenient that is. We know the 5th root of 32 is 2. This is the same thing as, oh dear, 4, or sorry, I want to rewrite this. Here, okay. So we've got our base is 32, our numerator is 4, our denominator is 5. So we're going to plug that into this expression right here, telling us that underneath our radical, we've got 32 to the 4th power, but take the 5th root of that. Look at this circus we have going on. Okay, so remember this 4, he can go outside of that. So I'm going to do that because it's going to make our lives just a little bit easier in what turned out to be kind of a nightmare of a problem. The 5th root of 32 we said earlier was 2. So we have 2 to the 4th power. And then we have the 5th root of 2. I'm going to take this 4 and distribute him to both. 2 to the 4th, a to the 4th. Oh, hey, now we need to figure out what is 2 to the 4th. Hey, well, 2 times 2 times 2 times 2 is 16. So that gives us 16 times the 5th root of, hey, 2 to the 4th. I've seen that before. That's 16. A to the 4th. Oof. Thanks for sticking with me. That problem got way tougher than I thought it would. Yoink. Oh well, how do you eat an elephant? 1 bite at a time. So we simplified that 1 bite at a time. So here you go, just break it into tiny bits, and here we go. We'll work on it together. It'll be great fun. Okay, exponential form. You know, guys, let's bring this guy down here. Whee! Okay. So now we want to figure out how can we write this with exponents. Well, I see that my base is b. I see that my power is 3 and my index is 5. So that tells me that, oh dearest, that my base needs to be b and my numerator needs to be 3 and my denominator needs to be 5. B, because it's b. Oh, look, we're done. That's exciting. B to the 3/5 power. Great. Look at this guy. Okay, so do not be fooled. This 5 only belongs to this d. So that means this is actually the same thing as the cube root of 27 times the cube root of d to the 5th. If you want to split it up like that, that's fine. You can also think of this as, and this is the way I prefer to do it, cube root is the same thing as a 1/3 power. So this is 27 to the 1/3 power. Just kidding, forgot the other half. 27d to the 5th to the 1/3 power. And then we can distribute that 1/3 to both, giving us giving us 27 to the 1/3 power times d to the 5 to the 1/3 power, which is 5/3 power. That's a lot of steps. I will break that up. Okay, d to the 5th power to the 1/3 power. So see how we distributed that 1/3 power to everybody. But check it out. Cube root, that means take the 1/3 power. So it's all equal. Now that we've come full circle, let's keep simplifying this guy. 27 to the 1/3 power. We're trying to find some number, 1, 2, 3, times itself 3 times equals 27. What is that number going to be? I should have made this all gray. Well, it's 3. 3 times 3 times 3 is 27. So the cube root of 27 is 3. That was clean. And then remember, when you have powers multiplied, or I gave it away, when you have a power raised to a power, you're going to multiply them together. So that'll give us d to the 5 times 1/3 power. Or, if you're a genius, you know 5 times a third is 5/3. And you just hopped right to that conclusion. That's great. Good job. Boom. There you have it. This is our pattern. This is a simplification of that pattern. Okay, remember where you have like a little hidden 1. So this guy is 1. Key idea right here. If you have a radical, the index is the denominator of the exponent, and the exponent is the numerator of the exponent. Remember to keep working little steps at a time. And have a great time on your homework, and I hope it's radical.